Are you struggling with acids and bases for your SPM chemistry exam? Yeah, you're not alone. It's a massive topic, but you know what? We're about to make it super simple. Think of this as your personal tutor's playbook. We're going to break down all the tricky parts so you can walk into that exam feeling totally prepared. Let's do this.
But hey, before we get into the nitty-gritty, let's talk about practice. Look, the best way to really get this stuff is by doing it. You can pop over to MCQ SPM.com or just scan this code right here to get your hands on real past year questions. Seriously, this is your training ground. It's where you'll apply everything we're about to cover.
Okay, first things first. Let's tackle the number one mistake I see students make all the time: confusing strong acids with weak acids. It's such a classic exam trap, but I promise you after the next few minutes, you'll see how simple it really is, and you'll never fall for it again. So, what is the real difference between a strong acid and a weak acid? A massive misconception students have is thinking it's all about concentration, like how much acid you've got in the water. Nope, that's not it. The entire secret, the one single idea that unlocks this whole topic is ionization. This slide right here says it all. A strong acid, over on the left, ionizes completely. That means every single molecule breaks apart, flooding the water with hydrogen ions. But a weak acid, on the right, well, it's kind of lazy. It only ionizes partially, so you end up with a much lower concentration of those H+ ions. So remember, strength is not about the amount of acid, it's about the degree to which it breaks apart in water. Now, I know that might still feel a bit abstract, a bit chemistry-ish, so let's use a really simple everyday analogy to make this crystal clear. Imagine a strong acid, like hydrochloric acid, is a chocolate bar you drop into hot milk. What happens? It dissolves instantly and completely, right? One moment you have HCl molecules, and the next, poof, they are all gone. All you have are H+ and Cl- ions swimming around. And that single arrow in the equation? That's your clue. It means it's a one-way street to full ionization. There's no going back. Okay, now think about a weak acid, like ethanoic acid. This is more like a hard candy. You drop it in water and what happens? Only a tiny bit of it dissolves. Most of it just stays there as whole molecules. That is the huge difference. And now look really closely at the double arrows in this equation. This is the detail that's going to win you marks. It means the reaction is reversible. Those ions can actually get back together and reform into molecules. It's a constant back and forth dance. So just to lock this in your brain, here is the official definition. Ionization, you might also see it called dissociation. It's just that simple process where an acid or an alkali splits apart into its charged ions when you dissolve it in water. That's it. That's the whole concept. And you know what the best part is? This exact same logic works perfectly for alkalis too. A strong alkali, like sodium hydroxide, completely ionizes. It breaks up completely, giving you a high concentration of hydroxide, or OH- ions. But a weak alkali, like ammonia here, only partially ionizes, which means you get a much lower concentration of OH- ions. It's the same principle, just with a different ion. Simple. All right, you've got the theory down. Now for the fun part, let's actually put it to use. How do the examiners test you on this? Let's take apart a real past year question, and I'll show you how to spot the answer in seconds. Here we go, a classic multiple choice question. Which of the following is a diprotic acid? This question is purely designed to see if you know your terminology. Now, the word that might throw you off here is diprotic. It sounds complicated, right? But it's not. It's just a code word. Once you know how to break the code, questions like this are basically free marks. So let's crack it. It all comes down to the prefixes. Mono means one, di means two. That's it. So a monoprotic acid can give away one hydrogen ion for each molecule. A diprotic acid can give away two. So let's look at our options. Nitric acid is HNO3. It has one H, but look at sulphuric acid, H2SO4. That little 2 is the giant clue. It tells you it can donate 2 hydrogen ions. That makes it our diprotic acid. See? Easy. Speaking of sulphuric acid, that brings us to another huge exam favorite, the contact process. This is the industrial process for making it. Now, there are a few steps, but examiners absolutely love to ask about its most valuable player. It's MVP, the catalyst. So, first, a really quick refresher. What is a catalyst? It's simply a substance that makes a reaction go way faster, but it doesn't actually get used up itself.
It's kind of like a coach who helps the team win the game but isn't actually on the field playing. And the MVP for the contact process, and this is a name you absolutely must memorize, is vanadium 5 oxide. Seriously, write it down. Say it out loud. Its one and only job is to speed up that one critical step, turning sulfur dioxide into sulfur trioxide. I can almost guarantee you'll see this on your exam. Now here is another little detail that separates the A+ students from everyone else. To make the final product, you don't just add water directly to that sulfur trioxide. Why not? Well, because it would cause a super violent reaction and create a dangerous fog of acid. Not good. So instead, the SO3 is dissolved in concentrated sulfuric acid first, and then water is added safely. That's a key safety detail they love to ask about. Okay, wow. That was a lot. So let's boil it all down into your final game plan. These are the absolute must-know takeaways for your exam. Here it is, your final cheat sheet. Number 1, strength is always about ionization, not concentration. Strong means it's 100% ionized. Weak means it's only partially ionized. Number 2, look for the arrows. A single arrow means strong, a one-way trip. Double arrows mean weak, it's reversible. Number 3, decode those prefixes. Monoprotic means 1H+, diprotic means 2H+. Number 4, the contact process MVP is vanadium 5 oxide. And finally, number 5, safety first. You dissolve the SO3 in concentrated sulfuric acid, not directly in water. And to leave you with one final challenge to really get you thinking, let's connect these ideas. You now know that strong and concentrated mean two different things. So, how would you prepare a solution that is dilute but still uses a strong acid? Think about the steps you take. If you can solve that little puzzle, it means you've truly, truly mastered this topic. Good luck.